Alright, you guys see that? I think so. Okay, so last week we had this. We got the spaceship, like physics to work, and it looks kind of weird because we have the square here. So what we're gonna do this meeting, the first thing we're gonna do is just get like the proper shape for this. So instead of a square like how it normally is, we're going to use a triangle to represent the ship. Mostly because I'm not very good at art, so we're just going to be making very simple shapes. Maybe later we will put in like an image. It all depends just how much time we have. So let's go into our player class, and in our player class we need to go player. We need to sort of define what does like each one look like, right? Like what does a triangle look like? Now what we're gonna make is a dictionary, so default underscore points. So we're gonna be representing the shape of the character using the points. So if I have 4 points like this is a square. If I have 3 points like this is a triangle. So we're just going to be representing the points in our list here, and we're just going to combine them when we draw them to make a shape. So default points, and to make a dictionary we use these curly braces, and we're saying that our square is going to be, and we're using the colon, and it's going to be a set of points. So this set of points is going to be just based on if we have the origin is right here. There's a point at 0, 0, right? We have a point at like this width, comma 0. We have a point at height, comma 0, and then we have width, comma height over here. Right? So this will make a square. So square, and the first point, pygame.vector2. We're using vector 2s so we can add them to other vector 2s, which you will see in a moment. So this is just defining like a regular square. So I'm just putting in all those points in the order that we made them. And we need 0, comma height. Perfect. Okay, now this is for our square, right? Let's make one for our ship. So ship is the next one, and then we need a list again, and we want to put in to this list the 3 points that make up a triangle. So let's think about this. Draw a diagram. We have 1 point here, this is 0, 0, and we want to go sort of this way, right? We want to go halfway between these 2 points, right? And we're going to go all the way here. So this is 0, 0, this is width, width, comma, height, divide by 2. This one is 0, comma, height. And then we can just put these points in. So we have pygame.vector2, 0, comma, 0, pygame.vector2, width, comma, height, divide by 2. And then finally pygame.vector2, 0, comma, height. So there we go. Now we have all of these default points that we're going to be using to define a shape. So we need to actually use this somehow, right? We can just make like a list of points. So self.points is going to be equal to self.default points, and we can just put in the mode. So no matter what mode we have, we will obviously have like a set of points that describes what this will look like. And then once we have all these points, what we can do is we can just draw them at the bottom. So let's go down to our draw function, and I can actually show you guys. You go click on structure. So on this side over here we have structure, you click on it, and you can see we have our player class. You can just click on one of these headings and it'll bring you. So this is update. We want to go to draw here. So right now we're just drawing a square, sorry. Let's delete all of that. Alright? welcome. We were just making our ship. So what we did is we just made like a list of points that defines what a square and what a triangle looks like, and now we're going to just draw it depending on what mode we're on. So we're going to do if self.mode is equal to self.square. Alright, this is why we made those variables earlier. We can just reference them easily like that. Just do pygame game.draw.polygon onto the screen with self.color, and we want to put in self.points. So this is just a list of all of our points, and then we can copy the same thing, and what we can do is we can just set the outline width to be this. And actually, I don't think we even need this. We can just delete that, and then Shift Tab to move it one back. Now, there's one thing you're going to see, and when we run it, you'll notice, okay, why didn't this work? Why is it just at the top, right? This is because these points that we made here, this is assuming that the origin is at 0, 0. This point here is going to be at 0, 0 on the screen, right? It's going to be right here. What we want is we want it to be where the player is positioned, which is right here. So how do we do that? We just add the player's position to that. So display underscore points is equal to self.position plus point for point in self.points. So here I used the list comprehension, and I'm looping through every single point, so for point in self.points, and since they're vector 2s, we can just add these together, and what this will do is you'll put it at the position, and then we just need to change this to display points, right? And boom, we have a triangle now. Alright, looks cool and all, but like it looks kind of weird. Like, don't you guys see, like, it's just like going up and down? Usually in Geometry Dash we have like if we have like triangle, it will be like rotating up when you're going up, of course, and like rotating this way when we're going down. It'll just make it look a lot nicer. So what we can do is we can make a function to sort of like rotate our ship, making it go tilt up and down as according to our velocity. Now let's make a function called rotate for now. So def rotate, and we need an angle to rotate at. And now let's make we're gonna have to make a copy of our current set of points. So we're gonna say points is gonna be equal to points.copy for points in self.default points self.mode. So we're using where is it? Over here. This line again, we're gonna get these default points, right? And then we're going to change those points. We're gonna rotate those points according to the angle that we have. And the reason that we aren't using our points, like our points variable, this one, self.points, is because we're going to rotate those points, and then we want to rotate it again, right? But then we'll have to calculate how much we rotated since the last frame, and that's all pretty confusing. So what we're going to do is we're just going to take an angle and rotate. We're just going to keep track of one angle. That angle is going to be how much you've rotated from the start, and it's just going to rotate it from the start, and that will give us our rotation. So we're going to have a new set of points, and we're going to set our display underscore angle is going to be equal to round angle. So what we're doing is we're just converting this angle, which is going to be in degrees. We're just going to make it into a whole number, just to make the thing look a little bit nicer. Sometimes, I don't know, when you just rotate it, it will look kind of off, like it's not completely at 0. This will just make it look like if you were at 0 degrees, you're going to be exactly straight, not slightly tilted. It's just makes it looks a little bit nicer. So now let's talk about rotation. So if we have an object, let's say a square for instance, and we want to rotate this object, well, Pygame gives us a function that lets us rotate a vector. So if you can imagine this to be a vector right here, so from this point here is the bottom, this is like the front here. What we can do with this vector is we can rotate this according to the origin here. So if, for example, let's say I had just a line here, a vector, and I want to rotate it like this way, let's say 90 degrees, then it's just going to rotate it like that. Okay, that's one line. How do we rotate this entire shape, right? What we have to do is we have to rotate, we want two things, okay? The first thing, we want to rotate it around its center, and the second thing is we want to rotate it just like as many degrees as we want, right? The entire shape. So what we do is we know all of these points, and we know like their relationship between. We know that they're like kind of like just related to this point right here, right? This top left corner, right? These are the three vectors for our angles, and this one is just 0. It's just ends at the starting point, right? What we need to do is we need to make this is our current pivot is right here. We want to make our pivot right here. How do we do that? What we can do is we can translate this entire square. So we can just shift it over such that we move, this origin point will stay the same, but our entire square will move. So I'm going to take this point, I'm going to move it to here. Okay? I'm going to take this point, I'm going to move it, right? So it's starting here, right? And then we're going to move it up like that. And eventually, if we do this with all the points, we'll find that our origin stays in the center. Does that make sense? Can you explain it again in a different way if you guys like? I think I'll explain it again, just in a different way. So let's say that we have like an origin right here, right? And then we have our vectors like this, right? And right now it's rotating around this point right here, but we want it to rotate around the center. So what we can do is we can translate this line right here. Like if I have the square that looks like this, right? This is my square. I'll make this, yeah, like this. This is my square. What I'm gonna do is I'm gonna shift this square so that this point of origin is in the middle. Now I can rotate this now because all of my lines will now be according to the origin, right? This is what happened to all of our points, right? And then when I rotate it, I just use the rotate function. I can rotate it however I like, as many degrees as I want, and then I translate everything back to here, and it's rotated for me. So let's put that into code. Alright, so we have our points, we have our display angle. For points in points, we are going to subtract the center, right? Oh, I forgot to define center. Let me do that really quick. So center is equal to Pygame.vector2, and that is going to be self.width divided by 2, self.height divided by 2. So what we did is I realized that this middle point right here, this is half of the width and this is half of the height, and that's all we translated this point by. So we translated this, like this, like this, and like this, and that's how we got that to the center. So what we do, translate it, and then we rotate point.rotate underscore IP, and just do the display angle. Then finally, we put the points back, And there we go. Self.points is going to be equal to points, and we're doing this like square brackets and colon, which just means copy. It's a faster way to do it in Python than .copy. So there we go. This function will rotate any set of points that we give it. So now let's go into our update, and then when we are to have a change in velocity, then we're going to be rotating it. Okay, so if self.mode is equal to self.ship, and old angle is going to be set to self.angle. Okay, no, we'll just do it like this. So angle is going to be equal to max min self.velocity dot y divided by 10, comma 30, comma minus 30. And then we'll just do self.rotate, self.angle. And oh, I forgot to define self.angle. We will make a variable called self.angle right here. Self.angle is going to equal 0. So now if our mode, if we have our ship here, if our mode is the ship, then we're going to set our angle to this, which I'm going to explain in a second. And after that, we just rotate our entire thing by that angle. And then let me explain what this is. So we're saying max of min of self.velocity.y divided by 10, comma 30, comma minus 30. So let's go part by part and explain, and I'll explain each one. So we're saying that that our velocity.y, we're using the y velocity because our player doesn't actually move forward. He only moves up or down. So this will depend. So if we have a ship like this, if we're going down, right? If we're going down, then that means our y velocity is going to be positive. If we're going up, that means our y velocity is negative. So if our y velocity, and we're just dividing it by 10, this is just a number that I found gave pretty nice results. If the minimum of that is between 30, right? So minimum this and 30. So for example, if our velocity was like 40, right? If velocity.y divided by 10 equals 40, and then we want the min of 40 and 30, what this is doing is essentially capping us at 30 degrees, and does the exact opposite with maximum. So basically our ship is not going to be able to turn more than 30 degrees in any direction. 30 degrees right here, right? It won't be able to turn more than 30 degrees in any of these directions. And that's just to keep us from having a ship that's like facing all the way backwards if you're going at a super high velocity. So that's it. And if you see, it turns up and down, which is great. I'm going to make the level a bit longer. So if you go to level 1.text, I'm just going to delete the 7 and put the 7 at the end. Now let's run it. I have a little bit more space to play with it, and as you can see, very, very cool rotation going up and down. Nice. Okay, you might have noticed it did look a little bit like not really smooth. So what we're going to do is essentially we're going to kind of cap how much we can move the angle by. So we're going to say that old underscore angle is equal to self.angle. And we're saying new underscore angle is going to be equal to this thing. So we're having the old angle and a new angle. And what we're going to do is if the absolute value of new angle minus old angle. So we're finding the difference, and we want the positive difference, so that's why we're using absolute value, because that makes everything positive. If that is greater than the self.ship display angle increment. Okay, this is a variable we have not made yet, so I'm just going to quickly make that. So I just copied that, and I'm going to go up here where we made some variables for our ship. I'm just going to set this to about 0.25. So remember, this is happening every frame, and we don't really want too much of a jump between each frame. So if this is less than 0.25 degrees, then what we'll do self.angle is equal to old underscore angle plus math.copy sine self.ship display angle increment, comma, new underscore angle minus old underscore angle. Okay, else self.angle equals new angle. And we can delete this. Okay, I'm going to explain this in a second. We do need to import math, so we're going to go into our setup and just do import math. And this will cover us for in here, because we imported setup, right? Let's go back. I'm going to explain this in a second, but I'm just going to show you guys. It just looks a lot smoother, right? A lot smoother. Perfect. Like, look at that. It's still a little bit, but it's a lot smoother than what we had before. Now, let me explain what happened. So, we're saying that our ship, each frame, it can only turn itself by 0.25 degrees. That's a very small amount, but that's for each frame, right? We have like, I don't know, probably hundreds of frames per second here, right? It can only move this amount per frame. And that means that what we're going to do is the old angle is going to be whatever angle it was before. So let's say it was like perfectly straight, and then the next frame we hit the up key or space key, and it makes the angle, it's saying the new angle is like this, right? But our old angle is this. What we're doing is, if this difference is greater than the increment, which it definitely is, right? Then we're going to say that we're going to say our new angle, or like the angle that we're going to use, is going to be the old angle, so this 0 plus math.copy sine. Math.copy sine will just take the sign. So if we have 5, it's a copy sign is going to give us positive. And then if we have like -6, copy sign is going to give us minus. So as you can see, it just gives us the sign that's in front of a number. It's going to steal the sign of new angle, this one, minus this one. So this is, let's say this is like 30 degrees, and this one is 0. So 30 minus 0 is 30, which is positive. So that will make us go up. And it'll do the exact opposite for, if new angle was here, then this one would be like minus 30 or something, right? Minus 30. So minus 30 minus 0 will give us a negative number, so we'll steal that number, and it'll make us go down like that. So yeah, and then otherwise, if our angle is within the ship angle increment, then it'll just go up by that angle. So yeah, there you go. Ship is basically almost there. We just have to do a few things to tidy this up. The first thing, of course, which is actually making a way for us to get into the ship position, right? Like right now, we kind of done it kind of manually, where we just set the ship as this, and we have like the points here. What we're going to do is make a function that allows us to switch the mode of our character. So right now we have 2 modes. The first one is our square, the normal mode, and the other mode is our ship. So def change underscore mode, and we have a mode that we want to change to. If this mode is what we already have, we don't need to do anything, so we just return. Otherwise, self.mode is equal to mode, right? We're going to set our velocity to pygame.vector2 0, 0. We're going to set our jumps to false, so we're just kind of cleaning up a bunch of variables, setting our angle back to 0. We're going to rotate to that angle back to default position. We're going to set our points to self.default points, self.mode. So just kind of doing like all of these things in the init all over again, but we're just careful to not just not like over. We're like being careful not to like overwrite anything that might be important, like the position and the acceleration, right? Also, one thing I neglected to do was add this copy one, because when you set a list is equal to something, so this is a list, we set something equal to this. If we make any changes to this, it could affect these, so it's just safer to just put in a copy like that. That's only for Python though. So lists are something called mutable, which means that like if you set a variable to it, it could change if you change that variable. Now, let's go back to our change mode function. If self.mode is equal, if mode is equal to self.square, then we want to set the acceleration to pygame.vector2 0, self.gravity. And we can literally copy, this is gravity.y, copy this and paste it again, and if the mode is equal to the ship, then we have the ship gravity, which we need to do ship_gravity. And yeah, let's set this back to its default, which is the square. And then what we can do is self.mode is, or self.change mode to the ship, which is self.ship. So this will be exactly the same as what we had before. Nothing has changed like for us visually, but we've just made our code a little bit neater. Alright, perfect. Now if we don't have this line, we'll just have the regular square again. As you can see, the velocity is not, or the accelerate, oh my goodness, that is not good. Oh, here, ship gravity. See, we made a mistake right here. Make sure you guys always test your code. Make sure it is not, if you made anything for testing, then you always change it back. There we go. That is our square again. Perfect. Okay, I think we have enough time. So our next thing that we're going to do is we're going to add portals into our game. So Geometry Dash, whenever the player goes through a portal, right, they go into it, on the other side they come out as a ship, right? And when you go into another portal, right, and then you come out as a square. So let's make these portals that will change your mode, and we can conveniently use this change mode function to help us. So let's go back into our file structure here. I'm just going to right click on my game and add a new Python file. I'm going to call it portal.py. Now in portal.py, it's going to be very similar to what you guys have seen before. So from setup import star, I'm going to do class portal. I'm going to do the width. This is equal to 50. I'm going to do the height is equal to 200, and we're going to set the color is going to be equal to, now depending on the type of mode that it'll change you into. So for example, if we have the ship, right, that's like a purple portal, and if you have a square, if you go into a green portal, it'll turn out to be a square. So we just have these to distinguish what type of, what mode is going to be changed into next. So square, so if our mode is square, right, then we want that to correspond to 0, 255, 0, which is green. Otherwise, if it's a ship, then we want it to correspond to 179, 0, 179. And that will be the color, and then we just need to do the same thing for our outline color. So we just duplicate that and outline color, and we'll just set this to a value that is a bit lower, which will make it darker, right? If you guys think about it, we have like the colors here. If we have black is 0, 0, 0, 0, 0, 0, and you have white So this is black. This is white, which is 255, 255, 255, right? Then whatever's in the middle is going to be gray, right? This is going to be 128, 128, 128. So if you have lower numbers, it's going to get darker. And the higher numbers, you're going to get lighter. I don't even know if you can read that. So yeah. Alright, so lower numbers, darker, higher numbers, closer to 255, it'll be whiter. Okay, great. So those are the colors, and I set the width to 50 and the height to 200, just so that we can put the portal kind of in the air, and it will have like a large area that it can affect the player. And then we're going to set the outline width is equal to 3, and the border radius is equal to 15. And we're going to do def underscore init, and we just need the position, we need the mode. So these are our parameters that we need to know. So self.position equals pygame.vector2 position, and self.mode is equal to mode. And then we need to make an update function, def update, and we need to know the delta time and the camera speed. These are all very similar to things we've done before. .x minus camera speed .x times delta. And then finally, we need the draw function, so draw and screen. And then all we need to do is just draw onto the screen our thing. And I did make a little adjustment to it because right now, like if we were to draw it onto the grid, I'll choose black. Yeah, there we go. So right now we have a grid like this, right? It's like a grid system. And if our portal is like going the entire thing, it looks kind of weird. So what I did was I made it this one all the way, but it just goes slightly underneath. It just draws slightly underneath that border there, so it'll just draw the portal like that. And it looks like it's hovering off the ground. So pygame.draw.rect. So I'll show you guys how to do that. So you want to draw on the screen. That's the first parameter. You want to draw self.color. And when you use self.mode, right? So according to the mode, right, of the player, or that this portal makes the player, it'll have a different color. The next thing we need is a rectangle that represents like the dimensions of this portal. So self.position .x, self.position.y, but we're gonna add 0.025. This is just a number that I found works. So times self.height. So this is like 2% of the height is just, we're just gonna take that away. So we're gonna just add that to it, and it's just gonna make a little gap between the top of the actual tile and where the portal actually is drawn. And then we want to do self.height minus times 0.95. So if you think about it, we've taken 2.5% here of the height, and we've taken 2.5% here from the height. So in total, these two sum up to be 5% off of the height. That's why our height is this one right here. This is going to be 1 minus 5%, which is equal to 95%. Okay. So yeah, that's why we have 95 right here. And then I need to close the bracket, and we'll put in border underscore radius is equal to self.border radius. So this will just give it like a curved appearance. Yeah, that looks good. Why is it giving me an error? Cannot assign to function call. Pygame.draw.rect. Do we make? Yeah, we have a border radius. Okay, I don't know what's going on there. Let's see. What is the error? Unresolved reference self. End of statement expected. Okay. Is just an extra parentheses caused the compiler to get confused. And yeah, so I just reformatted the file, and now that looks a little bit better. Just put this on another line. Maybe put this over here. There you go. Now it's only 2 lines. Good. So we can do this, and we can duplicate it all, and we can just add in outline just before the border is self.outline width. What this will do is it will draw our thing, but now we need to actually get our portals into the game. So we go to our game class, and we go to the top, and we'll just do from portal, import portal, and we'll have a list of portals. So self.portal equals this, and then we will just go into our level importer, and if we have the type is 8 and 9, so these will correspond to a different type of portal. So we want a portal I want to append a portal to this. Okay, this is the position. This is good, but we just need another parameter just to tell the portal what type of portal it is. So this would be player.ship and then player.square. Alright, make sure that's in all caps. And then we just need to update the portals. So after we update our spikes, we'll just do for portal and portals. It should be self.portals. Portal.updates delta and self.camera speed.x. Make sure this is not .x here. We just want to pass in the camera speed. Like we're going to be passing in the camera speed.x by itself, so we just want to keep this consistent with everything else. So all I did was I went to portal.py and removed that .x here. And then we will go and draw them. So we will draw our portals on top of our spikes. So for portal in self.portals, portal.draw screen. We won't see any if you hit run, because we actually need to put them into our level importer. So we will put it into we'll put it like here, I guess. So we want to go 1, 2, 3, 4 spaces up. That's just how we coded it. I'm going to go over here, put a 9. Now if we run this, and you can see we have a portal here, and it didn't do anything because our player isn't actually checking for these portals. So we need to go pass portals into our player. But as you can see, like we have our portals here. They're looking pretty cool. They're kind of hovering off the ground, and they're the right colors. Right, this green will change us back into a square. So let's go into our player, and we need to go into our update. And we want to just look after here. We just want to get all the portals that we could possibly keep track of. So we're just going to look through each portal. For portal in self.portals, we'll do portal dot if self.colliding with portal.position.x, portal.position.y, portal.width, and portal.height. And then we want to do if we do that, we want to change mode to the portals dot mode. And this should not be self, this should be just portals. Now we need to go back into game and put that into our player's update function right here. We just want to pass in self.portals. And if we run this now, you should see as soon as the player touches the portal, it will be turned into a ship, and when we pass through this portal, back into a square. Let's go test it in case like we jump over the portal. So if we jump over this green one, as you can see, we'll just still stay as a rocket ship. So yeah, there's that. I think, yeah, there's one more thing we need to do. So you might notice that when we hit the portal, as soon as our player touches it, it just turns into the ship. Let's make it so that like when you're inside of the portal, that exact moment, then you will be turned into the thing. So we'll just go do this exact same thing where we just add the width of the player. The same thing as we did with the goal, we're going to do that with the portal. And as you can see, transition is pretty seamless. So that's cool. Alright, so yeah, that's it for this meeting. Hope you guys enjoyed it and maybe learned something. If you have any questions, please ask me. Hopefully the meeting recording this time should have audio, so I'll be able to post that on YouTube. So yeah, thanks for coming.